Welcome to Brain Vision.
Okay, so we're doing chapter 26, problem 61. So it says a battery with an EMF of 12 volts and internal resistance of 1 ohm is connected to two 7.5 kilo ohm resistors in series. And it says an ammeter with internal resistance, so this is A, of 0.5 ohms measures the current. At the same time, a voltmeter with internal resistance 15 kilo ohms measures the voltage across one of the resistors in the circuit. And it says, what do the ammeter and voltmeter read? Okay, so let's first find by the equivalent resistance of the circuit. In series, we have the 1 ohm from the battery. We have the 0.5 ohm from the ammeter. We have 7.5 kilo ohms from one of the resistances, or one of the resistors, and the other resistor is in parallel with the internal resistance of the voltmeter. Okay, so that's how we add those in parallel. So if we add all this up in our calculator, we get an equivalent resistance of 12501.5 ohms. Okay, so now the current that this produces is going to be the current that the ammeter reads. So if we want the current for the ammeter, this is just given by the EMF over the equivalent resistance. So we have 12 volts over 12501.5 ohms. And this comes out to being 9.6 times 10 to the negative 4 amps. So this is the current that we would read. The voltmeter reading will be the source current times the equivalent resistance of this section, or the voltmeter combined with the resistor resistance. So Req of V and R is now 1 over 75 kilo ohms plus 1 over 15 kilo ohms inversed. And now we can find voltage from the voltmeter that we read, and this is just I from A times Req of VR. So this is 9.6 times 10 to the negative 4 amps times 1 over 75,000 ohms plus 1 over 15,000 ohms inversed. So if we plug that in our calculator, we see that it will read a voltage of roughly 4.8 volts. Cool.